Alright everyone, let's jump right in. So the first thing I'm going to take you through is the new assets that I've imported into the scene since the previous video, which is the Jammo character, the official character from Mix and Jam, which is an amazing YouTube channel. You definitely should go check it out. And the reason we're using the free Jammo character is because he comes with his own animations, so we don't have to separately go grab free animations from Mixamo. And I'm also going to be using Animator Lite. I'm not going to be using any of the animation features of Animator, even though I think that they're great. I'm going to be using only the finite state machine. We're going to use the Animator finite state machine implementation because it's really good, it's really well documented, and I learned a ton about both Unity and C# by working through the Animator examples on his website. So this is the finite state machine that we're going to use. I've already imported it. This is the character that we're using, and I've already imported it. I've also changed our controls just a little bit, which I'll take you through now. So if we go to controls, I've added one more control here, one more action, which is the run action. It is of type button, which means basically that it's either true or false. I've assigned it to the shift key and the left stick press on the gamepad. So I've added that, and then once I added that control and saved that control, I changed the name of our input controller to input manager, and you'll see why, because I want to use controller to mean something slightly different in this tutorial. And in the input manager, well, we have what we have before. We have this move performed and move cancelled, where we just read in the values from the move vector and run this Unity event that we defined. But I now also have this run action, and what I've done with the run action is defined a separate Unity event called the run input event that takes a Boolean. This is now another event that can be subscribed to in the editor, and it does exactly the same thing that the onMove does. It just reads the value from the context when the action is executed. Read value as button is going to return true or false, and then it runs the associated event with that Boolean value, true or false. And again, I've subscribed to both the performed and cancelled. So I'll get a true when the run button is held in long enough for it to count as being performed, and I'll get a cancelled when the run button is released. So I'll get a true and then false reading into these events. And that input manager is sitting on my game manager, and here you can see we've got the two events. Currently they have nothing inside them. Okay, those are the new assets that we're using, as well as what I've done to set up the input manager. We already know how to set up an input manager. We know how to do the controls. We've seen all of that in the previous tutorial. So the next thing that I want to talk about is what we're going to build. Overview of our architecture. And our architecture is going to look like this. The reason we're using a state machine is that we want the things that are connected to the character to always be defined in one place. What we don't want is for the character's movement and the animation that governs the character's movement to be separate, because then that's two places that we need to manage the game code. We don't want to do that. So everything that relates to the character's movement, its grounded movement separate from its airborne movement, for instance, I want in one place. And this is the architecture that we're going to use to do it. Our central piece of code is going to be the character. Not a central piece of code, but rather our core component is going to be the character component. And it's always going to contain the animation system that governs the character, the state machine that we're going to build now or set up now, the default state for the state machine, a character sheet, which is just the statistics of the character, and a character controller. So the state machine is going to consist of states, which we're going to call character states. Every character state is going to have a reference to the character so that it can grab components that it needs by going through the character to the components that it may need. As an example of the states, we're going to create an idle state and a locomotion state. Now, the idle state and the locomotion state are only going to govern themselves. They're not really going to change state ever. They're not managing the state machine. Instead, the state machine is going to be managed by our character controller. Now, what you could do is have your character controller as a base class, and then you can inherit from it for different types of controllers. So you could have a character controller that's driven by your input, or you could have a character controller that's driven by some AI behavior, and the rest of the system can all stay exactly the same way. I'm not going to do that here. I'm just going to make an input controller called character controller, and it's going to be responsible for managing the inputs and changing states. So it's going to record the move direction, and then it's going to say, well, if this move direction is not 0, we should be in the locomotion state. Or if this move direction is 0, well then we should be in the idle state. So it's going to do this by telling the states to do something. Whereas on the other hand, the states themselves can't tell the character controller to do anything. What they can, however, do is ask the character controller for important information. This guy is going to hold a reference to every state it could need to change to. It's also going to hold a reference to the character so that it can look up character statistics if it needs them. So that's going to be the basic architecture for our system. We're going to start by creating the character state, character, and character controller scripts, and then we're going to fill them out one by one. Right in. So the first script that I'm going to create is the character state script. But I also know that I'm gonna need a character script and a character controller script. Now, I'm gonna jump to the character state first. And for my character state, this is going to be a state that works inside my state machine, and my state machine is coming from Animator. I'm going to use the Animator finite state machine. So I'm going to add that namespace over here, Animator.finite state machine, and my character state is going to inherit from state behavior, which is then going to take a character state. Now, I know this looks like I'm using a black box here for state behavior, but all you need to know about the Animator state machine is that a state behavior is a mono behavior, and when I enter that state, it's going to enable the mono behavior. When I exit the state, it's going to disable the mono behavior. So that's my character state. It's going to be an abstract class. I'm never going to instantiate any character state. All the states that I'm going to be working with are going to be derived from character state. And the only thing it's going to have is it's going to have a reference to my character. So let's do that right now. It's going to have a private but serializable private character, which is why I already created that script called character. This guy I'm going to assign in the inspector, but anyone can ask the character state what its character is. So let's give it a property, which is going to be public. It's going to return a character. I'm going to call this guy character with a capital C, and everyone can get it, but only the character state itself can set it. So that's what this property is doing. The get is going to return a character. Now, that's all I need, and I don't need the private set. There we go, because I'm setting this one, but if I get, I return the same one. That's all that I need in my character state for now. Now I'm going to go jump over to my character itself and just put in the stuff that I need into my character. And I know what I need because I've already sketched out my architecture. So, public sealed class character. What are the things that I need in my character? Let's go look. I'm going to need my animation system and my state machine. Let's jump into that right away. So I'm going to need a private, but I'll serialize the field. It's going to be an animator. I'm going to need a state machine. This I'm not going to serialize. It's going to be private inside here. It's going to be a state machine. And let's make sure that we include the right namespace using Animator. Finite state machine. And then I can declare a state machine that is of the type of my character state. That's the states that it's going to contain. And that's why I did character state first, because these state machines have to be constructed using obviously the types of state that Animator can handle, which here is a state behavior. And I'm going to call this guy state machine, and I'm going to give him a public get. Public get. I want everyone to get it, but only a private set. Yeah. So I'm going to get a public get so that other components can ask for this guy, but only the character can set it, just like I wanted to do incorrectly on the previous component. So what are the other components I need? I've got an animation system, check. I've got a state machine, check. I'm going to need a default idle state. Okay, so I'm going to have a serialized field. It's going to be private, and it's going to be a character state. I'm going to call this idle state. And I need one more thing. Oh, two more things, the character sheet and the character controller. Now, your character sheet could be a separate class in which you can contain all the statistics relative to all the statistics that pertain to your character. But for the purposes of this tutorial, I'm just going to make my character sheet a bunch of little properties, a bunch of little fields that sit inside my character. So let's make a header for it. And I already know what the values are that I'm going to need in my character sheet. This is going to be a float. I'm going to need a, sorry, I want to explicitly make it private. I'm going to need a float move speed. And I think a good default value for this is about 2. I'm going to need a float run speed. A good default value for this is about 5. And I'm going to need a float turn speed. There we go. Now I'm going to add a header for this section just to clean up my inspector a little bit, and this is going to be required components. There we go. Is that everything? We need a character sheet. And finally we need a character controller that we're also going to be able to drag in here in the inspector. Now, of these 3 components that we're going to link up in the inspector, 2 of them I need to be able to access from other parts of my architecture. One of them is going to be the animator, and the other one's going to be the character controller. Because as you can see in the architecture, the locomotion state may need to ask things from the character controller, and the way the locomotion state's going to do that is by going through the character, because it's going to hold a reference to the character. As for the animator, well, we know the states are going to want to be able to change the animations themselves, because that's the primary purpose of what we're working with. So let's write 2 quick accessors for them. One is going to be a public animator that just returns animator. And the same for controller. And this is a character controller. All it's going to do is return the controller that we've inside here. Now, the reason I haven't used auto properties is because I want to be able to assign these in the inspector. Okay, that's why I've done it this way. Is this everything I need here? I think that's right. Let's initialize the state machine in our awake method. All right. And in start, we'll move it to our idle state. Now I'm only going to use one function from the Animator state machine throughout this tutorial, and the one I'm going to use is called try_set_state, and the state I want to move to is idle state. And this is one of the reasons I didn't roll my own state machine implementation for this tutorial. All I'm doing here is saying, whatever your current state is, try and move to the idle state. And what try_set_state will do in the background is it'll check whether or not we're already in the idle state, and if we can safely move. So this is a very handy little thing to do. Of course, you can roll your own state machine implementation if you like to, and there are other general state machine implementations that you could use. So I think this is my character all done. So now let's jump to the character controller, which is the last script in which we haven't put anything yet. So let's jump to the character controller. There's nothing in our character controller, but we can go look at our architecture that we sketched out and figure out what it needs. Well, it's going to need references to all the states, and it's going to need a reference to the character. So let's do that. Right now we only have one state. Which is the idle state. And we're going to need the character controller itself. So that we can point to it. I'm going to give these guys headers because I'm going to have some more states in the future. And that'll just tidy up my inspector a little bit. Okay, before we go click play and do anything, let's create that idle state. Remember, character state is an abstract class. I can't use the character state directly. I have to create something that inherits from it. For that, we're going to create an empty state called idle that right now does nothing. So let's go create that. Let's open it up. Right now, all I want from this guy is that it is going to inherit from character state. If I get an error, it's because oh no, it's an abstract class. Yeah, that's perfect. Now I've got this idle state that just sits around. It is a mono behavior, but it is also a state that my state machine can accept. Now let's go chuck all of these components onto our player. Okay, onto my player over here, the first thing I'm going to add is the base one, which is the character. Then I'm going to add the character controller, which manages the input. Now I'm not going to add my states over here. They're all mono behaviors, and this is going to get quite full. Instead, I'm going to create an empty game object, which I'm going to call states, inside my player. And inside here, I'm going to create an empty game object for each state that I might want to add. And the reason for that is just it's really neat, and then it's really easy to see what states the player has access to. So let's go here and add the idle state. Now, you might be asking, why have I done a series of serialized fields that we now have to go full in the inspector instead of doing something like a find game object or get component? Now, I used to do a lot of get component in my scripts, and I've sort of changed my thinking about that, really due to reading the Animator tutorials and all the documentation, where the argument is made that it's actually better to expose these fields in the inspector so that when you add the character script, you don't want to have a require type of for everything that you might need, because everything that you might need might not sit on this game object, it might sit somewhere else, like in this example, the idle state sits over there. But you do want to make it clear what needs to exist for this component to function. So serializing those fields means anyone that adds this component immediately knows what's necessary to make this component work. And I think that's a good way to go about it. So that's what I've done here. So let's link up all these parts. Well, we need an animator. There's one on the Jamo character. We need an idle state that we've created over there. We need a controller, which sits on this guy itself. Our character controller needs a character, which sits on this guy itself, and it needs the idle state, which is over there. Now, if I press play, what's going to happen? Oh, this guy needs a character. Apologies, it hasn't been hooked up yet. Boom. A little bit yeah, that's all fine. When I press play, nothing happens. So I have this whole state machine, but it's not doing anything yet, right? I am entering the idle state when my game starts. We know that's happening inside the character itself, the character script itself. But right as of now, my state machine isn't giving me anything. To get something out of my state machine, we're going to start adding locomotion and movement. And then we're going to transition between our movement state and our idle state. So, now a lot of controllers would call this the locomotion state. I'm going to be fancy and I'm going to call it the ambulation state. And the reason for that is ambulation specifically refers to movement that happens by foot. Ambulation refers to walking. So I'm going to have an ambulation state. And this is going to handle my movement for me. It hasn't opened just yet. Ambulation state. And it's going to be a character state. Now with the state in play, I'm going to jump over to my character controller. I'm going to need another state over here, which is the ambulation state. And now I need my character controller to actually start fulfilling its function. Now if you remember from the architecture, the character controller is going to handle the input for me, and it's going to link up the movement direction. It's going to determine in which direction I'm going to move. Then whichever state needs the movement direction, which might be something like an airborne state, it could be traveling through the air, or in our case the ambulation state, can look up the movement direction by going through the character and to the character controller. Now to get the movement direction, just like we did in our previous tutorial, we're going to go and have some events that subscribe to the input events we have earlier. So let's do this, and then we have a public. This guy's going to do this guy's not going to return anything. Public void on move event. Let's call it, on move input. Let's call it on move input. It's going to take two floats, a horizontal and a vertical. Now you've seen this function before. It's exactly the function that we wrote in our player controller in the previous tutorial. So you can just copy paste this if you like. and it's going to write them. It's going to write these two inputs into our values, into our fields for this class. So we've got this dot horizontal equals horizontal, and this dot vertical equals vertical. What I also want to do is I want to subscribe to that running event. And this guy returns a bool, which I'm going to call run input. Now what I'm going to do with this, well, I'm going to have a boolean that tells me whether or not I'm currently running, whether or not that guy's down. I want that boolean to only be set inside here, but I want it to be able to be read from anywhere. So I'm going to use an auto property for that. Let's call it public bool is running get and private set. Now, other components can ask the character controller whether he's running, but other components can't set the running boolean of the character controller. All I'm going to say here is running is equal to run input. Cool, I've got those two inputs. We can take a moment here and debug whether they work. They won't work yet because what we have to do is actually go subscribe to them off our input manager. So we've got this move input event. I'm going to add one here, add one here. I'm going to drag in the player, which has the character controller here, and he's going to respond to on move input, and he's also going to respond to the run input. Now, because this takes a bool, Unity neatly sorts out for me which of the functions sitting on my character controller can make use of that boolean, the same as what it did for the move input over there. Okay, so now my movement is being recorded here inside my character controller, but my character controller has not yet set up my move direction. Now again, move direction is something I want to be able to get anywhere, but I only want to be able to set it from inside my character controller. So let's do a public vector2, vector3, move direction. It's going to have a get and a private set. I'm going to set my move direction in every update loop, because as my camera moves, my move direction is going to change. I'm already responding to the input over here. Now this update, the way I get my move direction, is identical to what I did previously. But for those of you who don't remember, and of course to see if I remember how to do it, let's do it again. I'm going to start by setting my move direction equal to the global up multiplied by vertical. No, let's see, global forward multiplied by vertical, plus the global right multiplied by horizontal. Now these vertical and horizontal have been updated both when the input key is pressed and when it's released. Now what I want to do is rotate that move direction to be in the direction that the camera is facing. I'm going to add a little component here, a private transform, to hold my camera transform so that I don't have to grab it on each loop. Instead, I'll grab it during start. And here I'll say camera transform is equal to camera dot main dot transform. Now, the camera forward direction that I want is the one that's projected onto the plane. So let's go vector3 projected camera forward is vector3 dot project onto a plane camera transform dot forward and vector3 dot up. The quaternion that matches my rotation is quaternion dot look direction look rotation to projected camera forward. And now I finally take my move direction and I pre-multiply it with the rotation. Now you've seen all of this before, this is all great, but let's now start using our states a little bit, right? Let's say if there wasn't any movement, if the move direction magnitude is less than some small value, so there wasn't any movement, well then what that means is we actually want to be in the idle state. Now this guy has a reference to my character, so he can go to the character, he can go to the state machine, We can go, oh, not that character. Oh, sorry. It's lowercase character. You can go to the character, you can go to the state machine, and he can try set state to idle state. For safety, and because I'm paranoid, I learned that from Sharp Accent, I'll also just make sure that this is set to vector 3.0, and then I'll return out of here. You don't have to do anything else. If my character controller picks up that there was no movement, well, go to the idle state, make sure the movement is set to 0, and exit your update. Otherwise, find out in which direction we're trying to move, and then go to the locomotion state. Sorry, the ambulation state. That's what we want to do. So my character controller is not responsible for any of my movement. It's not responsible for handling the movement. The ambulation state must do that. What it is responsible for, though, is determining in which direction we want to move. So it's sort of the brain of my character. That's what it's doing. Now the actual movement needs to be handled inside the ambulation state. So let's go to the ambulation state, which is a character state. This guy's going to have an update. Inside its update function, it's going to go get the move direction from the, it has a reference to the character, which has a reference to the controller, and there it's going to get move direction inside its update state. Now it's going to move in that move direction. How much does it need to move? Well, it needs to get the movement speed from the character, which is where the character statistics are. Now I'm going to make just a walk speed for now. So let's go into the character. I'm going to not create a property, but rather a function. Let's call this public float get move speed. And this is because later when I want to run, I want to add some logic to this. But for now, this guy can just return move speed. I'm going to do the same thing for turn speed. And again, the reason to write a function for this is later you could have some logic. Maybe you have air friction or things like that that changes your turn speed. There we go. Go to the ambulation state. We go to float move speed. Is character dot get move speed. And now let's move. What transform do I want to move? I don't want to move the transform of my ambulation state. That's a mistake, because the ambulation state is going to be sitting on a different game object. I want to move the transform of my character. So character.transform plus equals, how far do we want to move? Well, we want to move in the move direction, multiplied by move speed, multiplied by time.delta time. I'm also going to change my rotation here. Why are you complaining about this? Oh, transform.position. There we go. I also want to do my rotation here, and I'm going to do the rotation by rotating in the move direction so that we get a adventure controller, not a shooter controller. You already know how to do that. Quaternion rotation to move direction is quaternion.look rotation in the move direction. So now we're going to say character.transform.rotation is equal to quaternion.rotate towards, from where we are right now, character.transform.rotation to our rotation to move direction. And the speed that we want to do it by is, well, let's go get the turn speed over here. And let's break this over multiple lines so it'll fit so neatly. Okay, that's it. When we are in the ambulation state, we are allowed to move. When we're not in the ambulation state, well, the state will be disabled, so this update function won't be called. Let's go set that up in the inspector. create an empty game object to hold our new state. This guy gets an ambulation component. It needs a reference to the character. Let's make sure all of my state references are looked up. Let's go to the player. My character controller now needs a reference to the ambulation state. And what I want to check is ambulation state starts disabled. Let's press play. But when I move, my ambulation state becomes enabled, which is what we want. So now we have our movement, exactly the movement that we had previously relative to the camera, but instead it's being controlled by our state manager, not all in one place sitting on our player controller. So the next thing that we'll do is get in our run speed, and finally we'll do our animations, which will turn out to be really, really easy because of the state machine that we've already set up. Okay, in case you missed why the character wasn't rotating on the previous little run-through, it's because this turn speed was set too low for it to have an actual effect. So at about 360, then you start to see the turning rotation that we expect, which is this guy turning and moving relative to the camera like an adventure controller. So let's go create our animator controller. Now, what I don't want to do is I don't want to duplicate any of the knowledge, any of the architecture that's in my state machine into my character controller. So I'm going to create what's actually it's going to look pretty weird, I think, if you've never seen a character controller set up this way. Let's grab the character controller window. Sorry, if you've never seen an animator controller set up this way. This is my JAMO controller. Let's quickly go back to JAMO and make sure that it's assigned there. First thing that it's going to have, this is obviously going to have an idle state. This guy's called idle, and the animation is going to be idle. That's it. Then I'm going to create a blend tree. I'm going to call this blend tree Ambulation. And my blend tree is going to be driven by a parameter, not called blend, but called move speed. My blend tree is going to have 3 possible states, or it's going to interpolate between 3 animations, the first one being idle, the second one being walk, and the last one being run. There we go. Thresholds all look good, it goes along move speed. But what I'm not going to do is I'm actually not going to hook up my ambulation to anything. I'm going to directly switch to it when I want to use it. So let's go take a look at that. Go back to the scene view here. Go back to my Visual Studio. In my idle state, the first thing that happens when I enter the state is onEnable is called. When I enter the state, I want my animator to be in a specific state. I can get my animator by going to my character. And what I'm going to do is just enter that state. I'm going to enter it using a crossfade, so wherever I was from, I'm going to fade into the state. I'm not going to snap to it directly. When you enter a state, you have to give the state name as well as the layer that the state is on. So this has to be base layer dot idle. And I'm going to crossfade to it in 0.25 f. All right. I'm going to do the same thing in my ambulation state. In my ambulation state, when I enter the state, onEnable is called. And in here, I'm going to go character dot animator dot crossfade, fade to my base layer dot ambulation state, which wasn't hooked up to anything else, over 0.25 f. And the last thing that I want to do, of course, is set my ambulation speed, the speed of my movement inside my animator, to my actual move speed. I want to normalize this value, so let's do a move speed. And I want to divide it by the maximum speed that I could get out, which is the run speed. So let's get a quick accessor for that in my character. And let's call it I've missed one curly brace. That should do it. So whatever my move speed is, go to the character and divide it by the max speed. All right, what was that? 1, 2, 3 lines of code, right? I think so. We're in our idle state, that's good. Let's make sure that that is what's happening by looking at the state. We're in the idle state. Now the ambulation state, when we move to it, we're changing our animator states and we're going to the walk animation. That is exactly what we want and is a really cool way of hooking up your animator directly to your state machine without having to also create transitions inside your animator. The last thing that we want to do is have a run. So let's have the run. Let's go to our character controller. Is running comes from the run input. Now when we ask our character what speed to get, let's look at the controller that is running. If it's running, let's return the run speed. Otherwise, let's return the move speed. And I think that that's it. So I move normally, and then when I press shift, he starts running. That's Jamo running across the field. The last thing that I'm going to do here for you guys, because the tutorial is super long, is I'm just going to turn on my Cinemachine third-person camera, which is already set up. Whew! I got third-person movement. Look at him go. And that is how we establish and build a state machine for third-person animation that separates the animation out from the Mechanim Animator controller so that the animation is neatly handled in the same place that the movement is handled, inside the state machine itself. And that's another tutorial done. You guys should be really proud of yourselves for making it all the way to the end. I just again want to give a big shout out to Animator, both the tool on the Asset Store. I'm not affiliated with it at all, but I think it's an amazing tool. And 90% of what I learned about state machines, I learned from working through his tutorials and reading his documentation. So a big shout out to that. Of course, to Mix and Jam for the awesome Mixamo character. I know I said that we'd be connecting a free Asset Store controller, but we're going to have to do that next time because this video was too long already. So what we want to do next is we want to take a controller that actually does all the cool stuff that you need a controller to do, like check for grounded states and handle your velocity when you go over slopes. And then we want to connect that to our state machine and then use our state machine to add cool stuff like jumping, falling, and crouching. So I'm on YouTube, I'm on Twitter, and you can watch myself and Flux stream on Twitch. Thank you very much.